Okay, I'll just put here for another 30 seconds, then we'll officially start. Okay, let's start. So this workshop is mainly telling you why LangChain extracted that way and how I view LangChain. So before I start, how many people use LangChain in this room? Okay, there's a few. I know the problem is that they keep on changing the imports and this kind of stuff. So I created these slides in December and I was still able to run it this month. So the exceptions have stopped changing. It's a good framework to learn now. And without further ado, let's take a look at the first extraction of LangChain. Okay, so there are actually many models by different providers. From OpenAI, we have GPT and reasoning models, the whole family tree. Next row we have AX7B, and recently they released some OCR scanning, and from Anthropic we have Claude. Okay, so but if you take a look and we go and use their own native API, in order to send a request, so send an endpoint request in order to get a response, notice that for OpenAI it's chat documentation.create, but for Anthropic is just messages.create. So LangChain was like, oh, why not let's just unify the interface where we can call the different models. So LangChain is how you do it. So you can install their packages. So in this case, for OpenAI, they have LangChain OpenAI, or Claude, they have LangChain Anthropic. You guys instantiate their respective objects. Then we use the invoke method in order to send a message and get a response. Okay. So in order to, they also try to unify the way that we write messages. So in LangChain, the three different roles is actually system message, human message, and AI message. So what you need to do is that you just need to create a list of the different messages. So this is the system message object and human message object. Then after it gets instantiate the chat models. After instantiate the chat models, just use the invoke method. So as you can see, the same list of messages we use for both OpenAI and Anthropic, which is Claude. Okay. Now let's take a look at prompt templates. So prompt templates is prompts are static, but we want to make it dynamic, which is very important for retrieval-augmented generation. So what we need to do is that we need to find a way to inject dynamic inputs at runtime. So LangChain created this class called chat prompt template, where we just put a placeholder, drag in curly braces, and we just fill it in dynamically when we want it. So how we fill it dynamically? We again use the same method called invoke. Okay. And just placeholder is the key, and you can just put in the value of the dynamic value that you want to fill in runtime. So this is a very useful thing because we're not repeating the same prompt. We do not need to write this entire prompt. We can just write this template, then after that we just invoke the dynamic parts. So you don't need to write this entire thing. Okay, so what is reg? Reg is just, you just put the information inside your prompt. But we need to find some way to get the information inside. So the first step of achieving retrieval-augmented generation is simply just using prompt templates. So this is a very simple context, right? So in this case, I just create a template with two different dynamic inputs. So what we need to do later in our chain is to just find a way to insert this custom data that we need. Data will take only. So in this case, I did it manually. I just say AI is artificial intelligence, what is AI? So this is already read, where the information that we need is already extracted, then we ask a question before the model gives us a response. Okay, yeah. Before that, let's go to Collab and see some code examples. Package, he actually installs two different modules, which is your LangChain and LangChain Core. So LangChain contains all of the pre-built chains that the developers have created, which they can just use. But LangChain Core actually contains the abstractions that we're talking just now. So just now we talked about messages and chat models. These belong to the LangChain Core package. So LangChain Grok is Grok is a LLM provider which will give you access to the open source models for free with quite a generous rate limit. So you can just install their external package. Then in order to load the document and create a vector storage for us to retrieve our data at runtime and input it dynamically into our prompt template, we also need to use this package called LangChain Community, which is a community maintained package with all the different integrations. So what kind of integrations can you find here? You can find integrations like PDF loader, you can find integrations like Notion loader, you can find other integrations to load in all the different office files. So these are all situated in LangChain Community. So this has been quite extended for a few months. So last time at version 0.0, 0.1, we used to import the LLMs from LangChain or LLMs. But then now it has been standardized. It's either in LangChain Community or LangChain with its external package like LangChain OpenAI, LangChain Grok, LangChain and True. So if you follow the guide, you will notice that you have inserted the keys in your collab secrets. So you just need to make sure you added the Grok API key and the Hugging Face token, which is inside the Google Docs. So if you follow these instructions, you will naturally be able to add the key. Okay. So now we need to just sync the keys that we store in Google Colab into our environment variable. For us to do that, we will just import the user data function from Google.Colab, which allows us to access our secret keys. Then we import OS in order to store it as an environment variable. Okay. So then we set the environment variable to Grok API key to the one that we got in Google Colab. Yeah. And it's the same thing, but this is the Hugging Face API key. So Grok is also a free LLM provider, which actually provides you access to numerous open source models like Llama or the Mistral 8x7b. So they actually contain a list of the free models that we can access from here. Let us just take a look. Yeah, so you'll be able to access these models. Later, if you want to change the model, it's very easy. The string which write Mistral, we can just copy and paste the model name from here. Okay. So in order to start, just now we say that we need to create some messages in order to send to the different chat models. So let us just create some. Okay. So first, we just instantiate our chat model. So again, it's from the LangChain, followed by the external provider name or the company name, LangChain Grok. Import check the company name. So these already set up the endpoint. Like this chat Grok object already set up the endpoint to the relevant link that you need to send a request to in order to get a response. And you just set it up into a variable. So in this case, I'm just using LLM. So if you run this set of two. Then now we will just create a list of messages that we need in order to send. So in this case, I just add a system message and a human message. So for those who do not know, system message actually is a system level prompt. It's the ruler of all your messages. It is used to direct the entire conversation flow. So if you set a system message to say that you must respond in Singlish, you will respond in Singlish for the rest of your conversation. So the system message, commonly you will put some stuff like what's the tone that you want your LLM to respond, what is the persona you want it to take, and its output format. Output format can be, please respond in JSON, please respond as a comma separated list. All of this will go to the system prompt. Then after that, we have our human message, which is just it's analogous to our human query, whatever we want to ask to the model. Then we have AI message. AI message actually is the same as the assistant role in the OpenAI API, which serves to store context or serve as memory for the entire conversation flow. Okay. So in order to use the messages, you need to import it from LangChain core because it's a LangChain abstraction. Okay. So we just import the messages, then we just store it in a list. Then with this, we can just pass in this list of messages and use the invoke method. So invoke method is a bit special. Later we will take a look at why is it called invoke, and you'll be able to get some response. So your response is originally here. You will see that your final response is actually stored in this attribute content. So you need to slice the object. So you just print the response.content and it will be tell you something about FOSSASIA. Okay. So if you want to build a simple chatbot, you just need to append whatever message that the model gives you back. So I just append the message over here. Then you have a new list which contain about the system message, human message, and AI message. So this is the flow. Then we can just add another question with messages.append human message. So in this case, I ask another question which is maybe relates to whatever the model responded to me just now. And when I re-invoke it, you notice that it will be able to give you a contextualized answer. Okay. So originally I designed this to be blank, but I think after I went through some workshops today, most people just show the code and run it. But I'll still walk through it. So the hands-on is for you to just create a simple chatbot with a while loop, so you can just ask away and chatbot will answer you. So let's take a look at how we can do it in Google Colab. We first import the chat model, then we just instantiate it with the proper model that you want, and the temperature is to make it more deterministic. Then after that, we set up our empty list of messages. Then we start our loop. So our loop will just receive any message that the user want to ask. But we need to have exit condition. So the exit condition is to just if the user type Q, we just quit out the loop. Then if there's a question, then we will just append it to the list. Then we will invoke it. So after invoking, you will have your AI response back, then which you can just print the content to the user. Then you continue to add back the AI message response, and the loop continues again. So this is how you create a simple chatbot with LangChain. Okay. So now we are at prompt templates. Prompt templates just now is actually just prompts, but you can dynamically fill it in runtime. So in order to start it, because it's another LangChain abstraction, we import it from LangChain core. It's over here. Then after that, we want to create our template. So to create a template, just call the prompt template class, and you pass in a list of messages. So because earlier on, our messages actually, you notice, we have some roles that we explain about, like system message and human message. So in order to also specify the role, we actually pass in a tuple of two elements. So the first element is whatever role you want it to correspond to. In this case, the first one should always be system. Then after that, it's whatever prompt that you want it to have. Okay. So in this case, I'm doing a translation task. So the phrase is the only thing dynamic at every single runtime. So I will just run it. Okay. So in order to populate our prompt template and make it an actual prompt to the model, we can just use the same .invoke method. So when we use the .invoke method of Sawadika, you notice that our prompt is actually filled. Because the human message translate phrase has now been swapped to translate Sawadika. Okay. Then now, if we take a look at the final thing, it's actually a simple list of messages that we can pass in through to the LLM. So it's a list of messages. So this perfectly fits for us to pass this into LLM before giving us a response. So if we invoke the prompt and we extract the content, we notice that we will get our final answer. So we say that the Thai phrase "Sawadika" is actually translated to "hello," which is not correct. So in order to do simple rec, just now we have seen, we haven't extracted the data yet. Now I just manually fill it in. I give it some information. So I just copied this from the FOSSASIA website. Just store it as a simple text. Then the prompt template is a bit special. I will have two different keys. I want to fill in the context at runtime, and I want to fill in the user question. So the context will just be equivalent to the information. So the information is the variable that I use to store whatever FOSSASIA is. Then the user can ask a question. So the question is just, in this case, it's just a function which I set the first parameter as prompt, and the prompt is the user question which I fill in over here. So if we ask a question, who founded FOSSASIA, it will just follow the system rules. So the system rules is that it should only answer questions related upon FOSSASIA. So if I run this, it will just see whatever is over here, and you will find the last sentence. FOSSASIA was founded in 2009 by Hong Kong Tang and Mario Belling, and it will give us the answer. Okay. Yeah. So this is how you can use a prompt template to achieve simple rec. But in this case, we are still manually inputting the information. In the later part, we will learn how to dynamically put the information. Yeah. Okay, let me return back to my slides. Okay. Yes. So you notice just now we are using invoke. Later we will run that. LangChain also created their own expression language. So LaSalle, actually stands for LangChain expression language, which is a syntax in order to compose components together. Because normally the output of one component will serve as the input for the next component. So in a simple LLM application, we just need to take in the user prompt, we pass it to the LLM, and we somehow from that object they give us back, we want to extract output and serve it to the user. So what LangChain do is that, hey, we define this interface called the runnable interface. So the runnable interface just specifies that, what inputs and outputs should a particular component have. So just now the prompt is actually form template. I take in a dictionary, I fill in the dynamic values at runtime, I will get back a list of messages. This list of messages is able to pass to the LLM. And the LLM will take in the list of messages and give us a AI message output, which you can slice the content. So the runnable in the interface is just a way for each component to receive input and output. This is the actual definition of runnable in the LangChain website. We just say that it's a custom component, or like you say, a function that can be invoked, batch, stream, transform, and compose. But in this workshop, we will only be taking a look at how it can be invoked, how it can be composed. Okay, so just now, to reiterate, we just want invoke is actually just translating some input and format it into some output. So just now the prompt template, we pass in some dictionaries with key in order to populate the field, and it will give us back a list of messages. Okay. Then for the LLM, it will take in the list of messages and pass us some AI message. Okay. So how do we compose the formatted prompt to the LLM? So what LangChain do is that I think it's a little bit of operator overloading, which we use this thing called a pipe operator. So the compose is just say that how can we pass information from one component to another without calling invoke multiple times. Okay. So now let's take a look at this. If I invoke it, it takes in some dictionary and it outputs a list of messages. So in this case, we just pretend it's a message. LLM takes in some message and gives out an AI message. And yeah, we are able to compose the output of this populated template in order to pass it to the LLM. What I think to do is that we just put in template and LLM, and we pipe the output of template using the pipe operator before passing it to the LLM. So in order to serve input to the first component of this chain, we will just use the input method. So in this case, the prompt template wants some context and question. So I just need to pass in some context and question, and you will automatically invoke it into the template, fills it up, return a list of messages to the LLM. Then the LLM will be able to process it. Okay, so now for intermediate Python users, you want to learn something called lambda, or lambda functions like as anonymous function. So just now, over here, we only pass it to the LLM. We want to extract the content attribute. Because now we talk about AI message, and the content attribute which we just want to show the user. So why not? We just going to write a simple function in order to return the content. So this is how you can pipe in this output parser in order to put it over here in the chain. So what you do is that we just say define output parser, taking in the output from LLM, which is an AI message, and just return the content. And after that, I will just put this function inside runnable lambda, and it can be composed with all other LangChain components. So this is the power of the LangChain expression language, where we are able to also write our own custom functions and put it into the chain. So in this case, after putting it in the chain, I can just invoke it normally. Okay. Now let's do more coding exercise. So over here, we have some, this is the table that I extracted of the LangChain documentation, which shows this is the LangChain component, which adheres to the runnable interface. Whatever input it should receive, whatever output it should receive. So in this case, let us take a look. We import the prompt templates from LangChain core again. We import our LLM, and we import the messages. After that, we compose a template over here, which is asking about what FOSSASIA is about. And then we define our LLM instance. So just now, in the earlier example, we actually needed to go and use the invoke method step by step. Template.invoke, fill out the template, get back a list of messages. Then after that, we pass it to the LLM. In this case, now let us take some shortcut. Let us just put these runnable components into a single variable called chain using the pipe operator. Then after that, we can invoke the entire chain, and we will get our response, which is over here. So we haven't added our custom function in order to extract the content. Let us see how we can do that. So we will use runnable lambda. We define our function in order to extract this content. So this extract content is just supposed to extract this content attribute. Okay. Now, if you type the output of the LLM into this our custom function and we ask the same question, we won't be able to actually say, FOSSASIA is founded in 2009. So it's a formatted message which can show in interfaces. So this is the LangChain expression language. So what is the important thing to take away from it is that the different components in LangChain often adheres to the runnable principle. So if you are building it specifically with LangChain, and building simple applications, you may not need to type LangGraph, but this is the traditional way of building it. And you are able to use your own functions inside the chain using this runnable lambda class. Okay, now for the most interesting part, we talk about data processing. Just now, our information is manually extracted. Now let's see how we can automate it. So in order to store this information, LangChain created another abstraction. So the abstraction is called document. So a document is just a simple class for storing text and associated metadata. So if I want to store some information that we want our chatbot to receive, right? We can just create a document object, populate the page content with the information that we want, populate the metadata. So this metadata thing is an interesting thing. It's actually just a dictionary of any arbitrary keys that you want. So maybe if you want to add the year of this document, you can also add it. LangChain also have different retrievers, later we'll talk about it, in order to only filter information based on the metadata. So all your text that you load in LangChain, it will be converted into this document object before it's passed to some vector storage to retrieve the proper information. So in this case, I just create my document object, and you can see if I print page content, it's the same thing as hello world. Print metadata is just this dictionary. So the thing that LangChain has is that it has a lot of document loaders. Just now I talk about you loading Notion, your own Notion repository, loading text files, loading PDFs. Actually, LangChain contains a lot of it. And after loading the file, which is community made, it will get converted into this class document. Then this document class. So for PDFs, what happens if you're just loading a PDF is that it will just split every page, and one page becomes just one document object. Yeah. So this is how you can simply load in a PDF. Most of the document loaders are actually stored in this LangChain community package, and you can just import the relevant loader. You can see the documentation for all the different loaders. Then you can just call the class with the name of the file or the URL link that you want. Then just call the load and speed function of this class. You'll be able to get back a list of documents. So this is how easy it is to go and load in some custom PDF in order to build your first RAG empowered chatbot. Yeah. But after we load in textual information, we notice that chat models have context window. There's only a specific amount of information that it can take, right? If my document is like 10,000 words, there's really no point putting 10,000 words into the prompt, because there can be hallucination and a lot of bad things will happen. So we will need to convert these documents into vector representation. So this vector representation is a point where we can use traditional computer science algorithm in order to find out which is the most relevant answer to this particular question that the user is asking. So we need to do this process called embedding. So to embed is to, why we embed is we want to find the most relevant documents that we have stored over here in the page content for the user question, and we want to pass to the chat model to prevent hallucination and to generate more context-aware answers. Okay. So I have these three sample documents. So if I map it into this three-dimensional space of AI, cybersecurity, and web development, Document 1 will be naturally closer to AI. Document 2 is a cybersecurity thing, and web development is a React thing. So if the user asks, so I guess give it some coordinates, this is just something different. So maybe this document where this coordinate of 1, this is 0, 1, this is 0, 0, 1. After that, when the user asks a query, it will also then embed it, and somehow through the cosine similarity, we will only get this relevant information. So all other external information is blanked out. The LLM will not receive, and it will only give you back this document, which is used to populate the prompt template just now in order to get our data, the most relevant answer. Okay. So we need to somehow store these numbers into a vector storage. So this vector storage is for us to just store this vector representation of the documents. And with this database, we are also able to search, use the user query and search out the most relevant document. So to embed the documents, you need to import an embedding model. I originally use OpenAI, but in the Connect notebook, I'm using the Hugging Face embedding, which is free and open source. Then for the vector store, we are just using this Files library, it's a Facebook library. So in order to convert all the documents just now into a vector store, just call this line. You'll call the vector store class, use the from documents method, which will convert your list of documents into this vector representation. So this is how easy it is in LangChain. Okay, so in this case, I manually just load the different documents. So in this case, from template and loader, document loader, and the vector store, whatever I explained now. Then in order to create this vector database, what I do is that I guess call the vector database class, use the from documents method, passing my list of documents over here, and passing the embedding model. Okay. So with this embedding model, we'll be able to use this vector storage, we'll be able to use this similarity search method in order to find the most relevant information. So if I try type in prompts in LangChain, it will also embed this question that I asked into the vector space and find out, oh, this is the most relevant answer that you want. So you can also set the K, which is the number of documents that you want to retrieve at one time. But there's a caveat, right? So this is one thing interesting about LangChain that people don't like. The vector store actually do not implement the runnable interface. I think the reason why is that the vector store can create data and you can upload some data there and you can also read data there. If you put an invoke method, it's like it doesn't know which one it should use for invoke. So what I do is that in order to retrieve the information just now, this similarity search, they create a wrapper over vector store. And this wrapper over vector store is just called retriever. So a retriever can only take in a user query and get back the most relevant document. And it supports the runnable interface. The moment it supports the runnable interface, it can be invoked. So if you want to just get back the most relevant query, we create a new object, a new retriever object using the .sRetriever method. It works for all the different vector stores like Chroma or Elastic. And we can just use the .invoke method, which is slightly different from the .similarity search. Okay. So this retriever will also retrieve for you the most the relevant data. It's actually just a wrapper over .similarity search. Okay. So to sort of summarize, in order to build a LangChain, we load in some data, we embed it, we store it somewhere, and we'll be able to retrieve the most relevant document at one time. So just now, we have talked about the prompt. The prompt is actually a prompt template which accepts the user question and the document information. So just now, we are loading in our document, and now we will embed it. So this is the pipeline. So the user asks a question. Once the question is asked, it will take in the user question and retrieve the most relevant information. Before passing it into a prompt, this prompt just gets sent to the LLM and you get an answer. This is how easy RAG is supposed to be. So the preparation of data, in this case, I never load it in. I just write whatever I wrote. So it's just a list of document objects. Then you can, if you want to load in your own data, you can just use this high PDF loader with the name of a PDF, call the load and split method. It will also return to you back a list of documents. Okay. Then we can embed this data by calling our vector store. Then we use the dot from documents method, which is in this list of documents over here. and we will embed. So you need to pass in the list of documents, pass in the embedding model that you want to use. Then remember, we need to convert it into a runnable in order to be composed into a chain, and we need to retrieve the relevant information, call the retrieval method in order to create a new retrieval object. Okay, so this is our prompt template. For a prompt template, can be just a prompt, which is answer this question based on the context only. So this is supposed to be system. Sorry. Then you can have a context over here and a question over here. So the context will be filled in at runtime by our retriever. And the question will just be the user question. Okay. Then we set up our LM, which is simply chat rock itself. In this case, it's open. Then we compose our chain together. So the first input of this chain is just your inputs for your prompt template. So in this case, is the context will just be assigned to retriever. We will take a look at why is it so later. Then the question is just runnable pass-through. Runnable pass-through will be going through later. Then we, after passing these two keys or these dynamic inputs that we need to fill at one time, we'll pass it to template. When the template is populated, pass it to the LLM before passing in the output cluster. Okay. So the chain works like that. When I invoke a question, the retriever sees this question. So because it's a runnable, it will automatically call the .invoke method on it. So when it calls the .invoke method on it, it will return to you back the list of documents, which is the most relevant to my user query. Because this is a runnable. Then this is my question, which is a runnable pass-through. A pass-through just receive whatever it takes. So it's just what to prompt template is to differentiate. So to repeat, now retriever is actually just this thing. Question is actually just this thing. Then this got populated into a prompt template. So just now it's almost the same thing. The context is really populated, and the question is really populated. So in this case, our prompt is really fully filled. When the prompt is fully filled, it gets automatically invoked by the LLM, which will process the data. Then we'll get back an AI message with a content attribute over here, which we want to extract. Then we can just run it by now. So this is your entire RAG pipeline. Okay. Let's see. So let us just start it. This is how you create a document. There's because it's a LangChain abstraction, so we import it from LangChain core. And we can just create our own document object. So this is how easy it is to create a document object. Okay. So for the purpose of this RAG course, really created this list of specifically type documents. So let me just run it, which create this list of documents. So this is the embedding thing again. When 3-dimension, we ask a question, what does AI stand for? Then the embedding model, after it's embedded, it will use some similarity matrix, and it will get back the most relevant information. And we will need to embed the model. So in this case, we are going to use some Hugging-based model. So it's actually stored in this .embeddings. And in order to access the API on Hugging-based to use the embedding model, we just call the class, put in our API key, and put in the model name. So the embedding model name in Hugging-based is just called all mini LM. And now we create our vector storage. So our vector storage is just something, just this FAISS. We call the doc from documents method. We pass in the list of documents over here, and we pass in our embedding model, which is this thing, embeddings. Then we need to convert it into a runnable. So this runnable is actually can be invoked, right? Then in order to limit the number of documents that get written, we can actually just pass in k. So if you run retrieval.invoke, you notice that it will give you back the prompt template and chat model, even though prompt template is above, because it's the most similar to the user question. So now we will just create the template that we have seen just now. It's just based on the following context. Context is a dynamic thing we want to populate in runtime. User query is the question is a thing we want to populate at runtime. And now we will we will pass in a dictionary into the chain. And this dictionary serves as the input to the prompt template. So, and this thing contains retriever. This retriever is a runnable. This runnable will invoke automatically at runtime, and it will give you back the most relevant document. The runnable pass-through will just take whatever I pass into the chain, which is a question. I pipe this thing to the template, which all the dynamic fields will get filled up in one time. After that, I'll have back a list of message. This list of message goes to the LLM. The LLM processes it. I pass it into my output parser as defined above in order to get back the information. And now, if I just input what from templates, it is able to say, with this ID, it's actually used to insert information, which is whatever I've written over here. Yeah, from templates are used to insert information at runtime. Over here, from templates are used to insert information at runtime. So this is where you know that it's really answering based on your own context. Okay. So if you want to use item getter in order to pass in the dictionary, you can also just do it. Okay, so here, if you notice something, actually I have a document with ID, but because I'm passing in, the retriever returns to you a list of documents. So you need to extract the page content, right? So this is a more complicated chain, but I think it's still understandable. So in the list of documents, what I do is that I just create a string. I join all the different documents, retrieve the page content into this thing, and pipe the output of the retriever to this thing. So I will just get back a normal message without the ID. Then if you print it now, you'll notice that it doesn't have the ID because we're just extracting the text. Okay. So this is the LangChain back pipeline. I'm actually done quite early. So if you want any help, you all can find me. Yeah. Thanks everyone. Okay.
So how you can control the size of the send to the model? Because look like to me that the chat for the ribbon document. You send to
the retriever will only like the key parameter is the number of documents that will be passed. So if you only put one and our document that we specifically chunk is small, they will just be that small.
The second question is that can I pass the function code to the model?
Yes, you can pass a function called but that's not covered in this talk. If you want to do that, you can use this framework called LangChain, which is quite easy to do that. So what you need to do is you just need to create a function, simple function. You decorate it with the add2 decorator. Then at the LLM, what you need to do is that you just use the .byTools method. So this .byTools method, the LLM is automatically set up in order to run the model. Okay.
What happens if you want to have a question that's answered by multiple documents? Like, tell me that several times where this happened.
It can be. So in that case, the retriever actually have many different algorithms. By default, we use cosine similarity. But in this case, what I want to do is that by default, right, LangChain retrieves 4 documents. But in your case, maybe you want to use something called the BM25 retriever. So it gets the most diverse outputs, or how many times I think is increasing. Then you just set K to a higher value. Yeah, then the LLM will process, these are the actually documents that is written back to me with this particular ID. Then the LLM see everything, then they say, only these 4 IDs actually written to me with the content that they want.
Yeah, my question is similar about the FOSSASIA. If we have many data sources, how to ensure about the information, all information was kept. For example, I have 10,000 of sources, and I have some prompt,
Okay.
and I want to ensure about 10,000 of information sources was read by some algorithm, how to ensure and without computational cutoff.
In that case, maybe you want to process it with traditional NLP. Maybe it's better if you want to see, because generative AI will just read everything. But with traditional NLP, you can actually go and count how many documents is have this particular content push inside. But if you want to do it in LangChain, I don't know why you can use that. You can actually just split the workload amongst different LLMs. So maybe you can have a hierarchical system where there's a parent node which say, this account. Then you just separate your different documents. Then the different documents just pass into a different LLM. The LLM will just give a number of this is the amount of documents that actually stated this information. Yeah. Then the parent will just say, since you are giving this answer, then this is the amount of times this information has appeared in the document. Is that your question?
But how we ensure that is there any law or anything to ensure about all of information have trace of query if a concern about the traceability of
the traceability of
the data source. For example, auditability, if you want to audit about data, maybe some of data source is
so you want to rank. You want to rank the data. I think that one belongs to the evaluation part. So LangChain has this it's commercial, it's called LangSmith. So LangSmith actually has this custom evaluation where the LLM is used as a judge to see how good is this name return back to you. There's a lot of this kind of open source evaluation frameworks used for this. So naturally we don't use this, we just use we just use an evaluator of LLM as a judge in order to tell me the flow. And then more question? No. Yes. I say more stickers if you want. I'll play at the counter.